This is the higher tier, paper 3 calculator paper from 2020. So it was supposed to be in June 2020, but because it got cancelled, it was actually the November 2020 paper. Question 1, so simplify n cubed times n to the power of 5. When we multiply indices, we add the powers. 3 plus 5 is 8, so it's n to the power of 8. N cubed means n times n times n, and it's multiplied by n to the power of 5, which is n times n times n times n times n. So in total, we've got 8 n's multiplied together. Part B, simplify. C cubed times d to the power of 4 divided by c squared times d. When we divide, we take away the powers. So c cubed divided by c squared. 3 take away 2 is 1. So we've got c to the power of 1 left. And d to the power of 4 divided by d to the power of 1. 4 take away 1 is 3. So we've got d cubed left. So what's going on here? We've got c times c times c times d times d times d times d on top. And on the bottom, we have c times d. So we cancel off 2 c's and 1 d, which leaves us with c times d times d times d, or c times d cubed. Part C, solve. 5x over 2 is greater than 7. So we want to get x by itself. The first step, get rid of the divide by 2. The opposite of dividing by 2 is multiplying by 2. So we double both sides, multiply both sides by 2, which gives us 5x is bigger than 14. Now x is multiplied by 5. We do the opposite of multiplying by 5, which is dividing by 5. So divide both sides by 5. And that gives us x is bigger than 14 fifths. X is bigger than 14 fifths. If we want to change it to a decimal, we can. It's 2.8. But we don't have to. I'm going to leave it as x is bigger than 14 fifths. Question 2. Andy cycles a distance of 30 kilometers at an average speed of 24 kilometers per hour. Then he runs a distance of 12 kilometers at an average speed of 8 kilometers per hour. Work out the total time Andy takes. Give your answer in hours and minutes. So we need to know that speed is equal to distance over time. If we want to work out time, we need to rearrange this, so multiply both sides by time. So speed times time is distance, and then divide both sides by the speed. Time is equal to distance divided by speed. So we're going to work out the time it takes him to cycle, the time it takes him to run, and then add them together. So for the cycle, time is distance, which is 30 kilometers, divided by speed, which is 24 kilometers per hour. So 30 divided by 24 is 5 over 4, or 1.25. So I'll put 1.25 hours. So it's 1 hour and a quarter, which is actually 1 hour and 15 minutes. But I'll do that conversion at the end. And then for the run, the time is distance, which is 12, divided by speed, which is 8. 12 over 8 is 1.5. So you can do it in the calculator, but I know the answer is 1.5. Again, 1.5 hours. So in total, so the total time is 1.25 plus 1.5 which is 2.75. So 2.75 hours. We want it in hours and minutes though. So let me just write 2.75. We want it in hours and minutes. 0.75 is 3/4. So it's 2 hours plus 3/4 of an hour, which is 2 hours and 45 minutes. On the calculator, we've got a button that will do that conversion for us. So this button here is a time button. It changes it to 2 hours, 45 minutes. So that's 2 hours and 45 minutes. Question 3. A number m is rounded to 1 decimal place. The result is 9.4. Complete the error interval for n. So what could this number have been before it was rounded? So we've got 9.4. The number below to 1 decimal place is 9.3. The one above is 9.5. So if we look halfway in between 9.3 and 9.4, and halfway between 9.4 and 9.5, we will find these bounds. So halfway here is 9.35. Halfway between 9.4 and 9.5 is 9.45. So it must be in between 9.35 and 9.45 to round to 9.4. And it can equal 9.35. That's why we've got this greater than or equal sign. But it can go anything up to 9.45, but it can't equal it. So it's less than 9.45. Question 4. Maisie knows that she needs 3 kilograms of grass seed to make a rectangular lawn 5 by 9 meters. Grass seed is sold in 2 kilogram boxes. Maisie wants to make a rectangular lawn 12 meters by 14 meters. She has 4 boxes of grass seed. Has Maisie got enough grass seed to make a lawn 10 meters by 14 meters? The lawn she wants to make. You must show all your working. So she needs 3 kilograms of grass seed to make 5 by 9 meters. So 5 by 9 meters is 45 meters squared. So 3 kilograms of grass seed is needed for 45 meters squared. Grass seed is sold in 2 kilogram boxes. So 1 kilogram of grass seed we need for 45 over 3, which is 15 meters squared. And so 2 kilograms of grass seed, each box, is needed for 30 meters squared. So each box of grass seed covers 30 meters squared. She has 5 boxes. So let's do 30 times 5, which is 150 meters squared. So that's how much she has. So that's the grass seed that Maisie has. She has enough grass seed for 150 meters squared. Her lawn is 10 by 14. So 10 by 14, 10 times 14 is 140 meters squared. So that's the grass seed she needs. So does she have enough? Yes, she's got enough for 150. She needs enough for 140. So yes, she has enough. Maisie opens the 5 boxes of grass seed. She finds 4 of the boxes contain 2 kilograms of grass seed. The other box contains 1 kilogram of grass seed. Does this affect whether Maisie has enough grass seed to make her lawn? So She has 4 boxes, 4 full boxes. So 4 boxes that do 30 meters squared each. So she's got 4 30 meters squared, which is 120. But then the other box only contains 1 kilogram, which will cover 15 meters squared. So 115 is 15. So she has enough for 120 plus 15, 135 meters squared. She needs 140, so she doesn't have enough. So does this affect whether she has enough? Yes. She will only have enough for 135 meters squared. Now just write in brackets, she needs enough for 140 meters squared. Question 5. Amanda has 2 fair 3-sided spinners. She spins each spinner once, complete the probability tree diagram, and we've got lands on 2 or does not land on 2. So because these spinners are fair, they must have an equal chance of landing on the 1, the 2 and the 3. So 1/3, 1/3, 1/3. So the probability it lands on 2 is 1/3, and the probability it doesn't, either 1 or 3, is 2/3. And it doesn't matter if it's spinner A or spinner B, they'll have the same probabilities, they're the same. So lands on 2 will be 1/3 and does not 2/3. Work out the probability that spinner A lands on 2 and spinner B does not land on 2. So spinner A lands on 2, spinner B does not land on 2. So when we go across the branches, we multiply. So it's 1/3 times 2/3. So times the top, 1 times 2 is 2, times the bottom, 3 3s are 9. Question 6. So we've got 2 graphs for us drawn, and the question says use these graphs to solve the simultaneous equations, and the equations are the same as the equations of the lines. So the solutions to simultaneous equations on a graph is where they intersect. So we're looking for the intersection of these 2 graphs. So we're just reading off what's x, what's y. So x is -2, y is 4. So x is -2, y is 4. So the solutions to simultaneous equations on a graph is the point where the 2 graphs intersect, where they cross. And part B. So we've got a graph here, a quadratic graph. We've got the equation given to us. And it says use the graph to find estimates for the solutions of the quadratic equation. And instead of y equals, it's equal to 0. So we're looking for the points where it crosses the x-axis. It's when y is 0. So when y is 0, it crosses the x-axis. So we're looking here and here. The roots of the quadratic equation, the roots of the quadratic graph are where it crosses the x-axis. So we have 0.6 and 3.4. So x is equal to 0.6 or x is equal to 3.4. Question 7. There is a total of 45 boys and girls in a choir. The mean age of the 18 boys is 16.2. The mean age of the 27 girls is 16.7. Calculate the mean age of all 45 boys and girls. So the mean is everything added up, so the total, divided by how many. And here we've been given the mean, and we've been given how many. We're going to need to work out the total. So we're going to work out the total age of the boys, then the total age of the girls, so we can add them all up and divide by 45 for the mean age of all of them. So for the boys, the mean is 16.2, which is the total age of all the boys added together, divided by 18. So if we multiply by 18, we'll find the total age of the boys. So 16.2 times 18 is 291.6. And for the girls, I'll quickly store this in the calculator because we're going to use that in a second. The mean age is 16.7, which is the total, divided by 27. So to get the total, we'll multiply by 27. 16.7 times 27 is 450.9. So for the mean of everyone, so the total mean, the overall mean, I shouldn't have used the word total again. So I just put mean, so the mean of all the boys and girls together is all the ages added up, divided by how many in total, and that was 45. So all the ages of the boys and the ages of all the girls added up and divided by 45. So I stored 291.6 as A. So these two numbers added up makes 742.5. Then divide by 45, and we have 16.5. Question 8. There are some counters in a bag. The counters are blue, or green, or red, or yellow. So that's shown on the table we've got. And so the table shows the probabilities that a counter taken at random from the bag will be blue or green. The probability that a counter taken at random from the bag will be red is 5 times the probability it will be yellow. So red is 5 times as much as yellow. So we can call them X and 5X. There are 300 counters in the bag. Work out the number of yellow counters in the bag. So let's find out what these are. So all the probabilities have to add up to one whole. So 0.32 plus 0.2 plus 5x plus x must add up to 1. So 0.32 and 0.2 add up to 0.52. 5x and x makes 6x. So let's we want to solve this for x. So take 0.52 away from both sides. So 1 minus 0.52 is 0.48. And that's 6x. So to get x by itself, divide both sides by 6, and we get 0.08. So 0.08 of the counters, so that 0.08 of the counters are yellow. There are 300 in total. So times by 300, and that will tell us how many yellow counters there are. There are 24 yellow counters. So 0.08 is like 8%. So 8% of the counters are yellow. So 8% of 300 is 24. Question 9. We've got a prism that's drawn for us here. And we've got some lengths on it, and we've got an angle given to us as well. The cross section of the prism has exactly one line of symmetry. So that's telling us that there's a line of symmetry down here. What it's really telling us is this triangle on top was an isosceles triangle. Work out the volume of the prism. So to find the volume, we need to find the area of the front, so area of the cross section, times how far back it goes. So the area of the front times how far back it goes. So let's work out the area of the front. We can work out this rectangle. The area of the rectangle is 10 times 12, which is 120 centimeters squared. But how can we work out the area of this triangle? So we've been given a 40-degree angle here. So I'm just going to look at this right angle triangle in the middle. So split the isosceles triangle in half. So we know we've got a 40-degree angle. A 40-degree angle, a right angle. And half of 10 is 5 centimeters. So if we work out this height here, the height of the isosceles triangle, we can find the area of the triangle using half base times height. So let's use SOHCAHTOA. So use SOHCAHTOA on this right angle triangle to find the height. And then once we've got the height, we can use half base times height to find the area of the triangle. So 40 degrees is our angle. So opposite it is this h that we're working out. The hypotenuse is the longest side, and in between the angle and the right angle is called the adjacent. We want to work out the height of the triangle. We know 5. H isn't in the question, so it's not SO, it's not KA, it's TOA, the one with O and A in it. And that means, TOA means tan with the angle is equal to O divided by A. So tan 40 equals H, the height of the triangle, divided by 5. So we'll multiply both sides by 5. So 5 times tan 40 equals the height of the triangle. 5 tan 40 is, we've got 4.195 and so on. I'm going to leave that in the calculator. So the height of the triangle is 4.195 and so on. So the area of the triangle is half the base times the height. Now I'm looking at the whole isosceles triangle. So I'm looking at this whole shape here. So the base is 10 for the whole shape. The whole triangle's got a base of 10 and it's got a height of 4.195. So the area is half times 10 times 4.195. So half times 10 times my last answer. Half times 10 times answer is 20.977. So 20.977 and so on. Again, I'm leaving that in my calculator. And so the area of the cross section is 120 plus the area of the triangle. So the area of the cross section is 120 plus 20.977. So answer plus 120, 140.977. And the volume is area of cross-section times how far back it goes, which is 20. So volume is my last answer times 20. So I've got 2,819.5, 2819.5, but I think it said 3 significant figures, so 1, 2, 3, so 2,820. 2,820 centimeters cubed. Question 10. A person's heart beats approximately 10 to the power of 5 times each day. A person lives for approximately 81 years. Work out an estimate for the number of times a person's heart beats in their lifetime. Give your answer in standard form, correct to 2 significant figures. So this question says work out an estimate. So usually we might round when we use an estimate, but it's already an estimate because we've got an estimate, an approximation for the number of times the heart beats in a day, and an approximation for the number of years someone lives. So it will already be an estimate without us rounding our numbers, and because we've got a calculator, we may as well use the numbers we've been given. So 10 to the power of 5 times a day, 365 days a year in most years, that's an approximation, and 81 years, so that many times a day, so that's a year, 81 years, and let's type it in the calculator. So 10 to the power of 5 times 365 times 81. So we've got 29565 and then 5 zeros. So give it your answer in standard form, correct to 2 significant figures. So 1, 2, the next numbers are 5, so it's going to round up. So it's going to be this, correct to 2 significant figures. And what number is that? So 6 zeros is a million. It's 3 billion. 3 times 10 to the power of 9. A calculator won't do a conversion into standard form for us. There is this ENG button, which actually will do it. So it only does it, I think, in multiples of 3, but it will actually give us 2.9565 times 10 to the power of 9. So that did convert it into standard form for us. What we could also do to check is if we did write in 3 times 10 to the power of 9, it would convert it back and we could count the zeros and check that we've got the right number. 2 times 10 to the power of 12 red blood cells have a mass of 90 grams. Work out the average mass of 1 blood cell. So 90 grams for 2 times 10 to the power of 12 blood cells. So for 1 blood cell, we need to divide by 2 times 10 to the power of 12. So it's going to be 90 grams shared out between all of those blood cells. Which is 4.5 times 10 to the power of negative 11. And that's our answer. Question 11. The diagram shows a triangle P on a grid. Triangle P is rotated 180 degrees about 0, 0 to give, about the origin, to give triangle Q. So to rotate it, I don't have tracing paper on this computer, so I'm going to have to imagine where it goes. So it rotates 180 degrees round. So this 1, 2 will spin round and be at negative 1, negative 2. 1, 5 will be at negative 1, negative 5. And 2, 5 will be at negative 2, negative 5. So this is where the triangle will go once it's been rotated 180 degrees. So that's triangle Q. Label that. Triangle Q is translated by 5, negative 2 to give triangle R. So 5 right, 2 down. So I'm going to take a point. I'll take it 5 to the right. 1, 2, 3, 4, 5. And 2 down, 1, 2. So that will be the bottom corner of the triangle now. And I'll draw the triangle from there. So 1, 2, 3 up. It goes 3 up. And this is triangle R. Describe fully the single transformation that maps triangle P onto triangle R. So how could I get from P to R? So it's a rotation of 180 degrees. That's how I got the shape. So what's the center? So the center of rotation here, let's join up these points, see where they meet. So they seem to meet at 2.5, negative 1. So it's a rotation, 180 degrees, about 2.5, negative 1. Under the transformation that maps P onto R, the point A is invariant. Write the coordinates of point A. So P onto R. So that's this rotation. Which point doesn't move for this rotation? The point that doesn't move is the point where you hold the tracing paper. So that is the center of rotation, the way you rotate the triangle about. So the same answer as the last one, 2.5, negative 1. So invariant means it's the point that doesn't move. Question 12. Express x over x plus 2 plus 2x over x minus 4 as a single fraction in its simplest form. So when we add fractions, we need to make the denominators the same. So to do that, we're going to multiply top and bottom of our left one by x minus 4. And we'll multiply top and bottom of the right one by x plus 2. So that will give us x times x minus 4 over x plus 2 times x minus 4 plus 2x times x plus 2 over x plus 2 times x minus 4. So now the denominators are the same. They're both x plus 2 times x minus 4. We can add the fractions. So I write this as one fraction now over x plus 2 times x minus 4. And I won't expand the brackets just yet. I'll leave them for now. and just write it as a single fraction. Now I'm going to expand the brackets. So the denominator is still the same. And I'll expand the top. So x times x is x squared. X times negative 4 is negative 4x. 2x times x is 2x squared. And 2x times 2 is 4x. So simplifying the top now. X squared and 2x squared make 3x squared. Negative 4x plus 4x is nothing. So we've just got 3x squared on top. And the denominator is x plus 2 times x minus 4. Part B, expand and simplify. So we're expanding the triple brackets. So we are going to leave one bracket at first and multiply and expand the other two. So let's leave the last one. So expand the first two. So x times 2x is 2x squared. X times 3 is 3x. Negative 3 times 2x is negative 6x. And negative 3 times positive 3 is a negative 9. And I'm leaving the second bracket as it is. Now collect like terms on our first bracket. So we've got 2x squared. We've got 3x take away 6x, which is negative 3x, minus 9. And now we're ready to expand again. So we've expanded the first two brackets, and now we're going to expand again with our upper bracket. So we're going to multiply each of the terms inside the first bracket by both of the terms in the second bracket. So 2x squared times 4x is 8x cubed, and then 2x squared times 5 is 10x squared. Negative 3x times 4x, so negative 3 times 4 is negative 12, x times x is x squared. Negative 3x times 5 is negative 15x. Now onto the 9, so multiply the negative 9 by both terms. Negative 9 times 4x is negative 36x, and negative 9 times 5 is negative 45. Now we just need to collect like terms and we are done. So we've got 8x cubed, we've only got one x cubed term. For x squared, so we've got 10, take away 12, which is negative 2. For the x's, we've got negative 15, take away 36, which will be negative 51. And we've only got one number, negative 45. So there's our answer. So we've got 8x cubed minus 2x squared minus 51x minus 45. Question 13. On the grid, show by shading the region that satisfies all of these inequalities and label the region R. So x is bigger than 0. So all of these are or equal to. All of these inequalities are or equal to inequalities, so they're all going to have a solid line. If it was just bigger than or less than, it will be a dotted line. So we're going to draw x equals 0. Where's x equal to 0? Any point along this line. So this is the line x equals 0. X is less than or equal to 2. So again, we'll draw x equals 2. So it's bigger than 0, but it's less than. It's bigger than 0, but it's less than 2. So it's somewhere in here. Y is less than or equal to x plus 3. So let's draw y equals x plus 3. So let's just get a few coordinates. So when x is 0, y is 0 plus 3. When x is 1, 1 plus 3 is 4. When x is 2, 2 plus 3 is 5. So 0, 3, 1425. And y is less than that, so y is lower going down, so it's this side of this line. And the last one, 2x plus 3y is bigger than or equal to 6. So again, we need to draw some points on this line. Let's do when x equals 0. When x is 0, we have 0 plus 3y. I'll write equals 6 for now. So 0 plus 3y is equal to 6. Divide both sides by 3, y equals 2. So on the line 2x plus 3y equals 6, we have 0, 2. And when y is 0, we get 2x equals 6. So x is 3. So we have 3, 0. So we've got 0, 2 and 3, 0. So we can draw them on. And that's when x and y are both bigger. So that's going up. So this is the region. And we'll label it R. And we can check this is true using a point. So the point 1, 3 is in the region. So if when x is 1, y is 3. So if we put x is 1 and y is 3 into these, they should all be true. So 1 is bigger or equal to 0. 1 is less than or equal to 2. 3 is less than or equal to 1 plus 3. So 3 is less than 4. And we've got 2 1s, which is 2, and 3 3s. So 2 and 9 make 11. 11 is bigger or equal to 6. So all of those are true. So this must be the right region. Part B. So the diagram below shows the region S that satisfies these inequalities. Jeffrey says that the point with coordinates 2, 4, 2, 4 does not satisfy the inequalities because it does not lie in the shaded region. Is Jeffrey correct? Well, no. And that, again, because these are solid lines, it means they can equal. We can see from the inequalities they can equal. So the lines will count. And we can check with 2, 4. So x is 2, y is 4. That this works for all of them. So y is 4. 4 is less than or equal to 4 times 2. 4 is less than or equal to 8. And the second one, 4 is bigger than or equal half of x, which is 1. That's true. And x plus y, 2 plus 4, which is 6, is less than or equal to 6. It is equal to 6. So it does work. So it does satisfy all the inequalities. So Jeffrey is not correct. When x is 2 and y is 4, all the inequalities are satisfied. And 6 is less than or equal to 6 is true. Question 14. Points B, D, E, and F lie on a circle, ABC is a tangent to the circle at B. Find the sides of angle ABD. ABD. So this angle here. That's what we're working out. You must give a reason for each stage of your working. So we can say opposite angles in a cyclic quadrilateral or cyclic quadrilateral add up to 180 degrees. So 100 plus this angle have to add up to 180. So DBF is 80 degrees, and that's because opposite angles in a cyclic quadrilateral add to 180 degrees. Then we can say that, well, we know BFD is part of this triangle. So angles in a triangle add up to 180 as well. 80 plus 40 is 120. 180 take away 120 is 60 degrees. So BFD must be 60 degrees because angles in a triangle add to 180 degrees. And now we know we can say that ABD is also 60 degrees because of the alternate segment theorem. So when we have a triangle in a circle, so we've got a triangle in a circle, the angle that the tangent makes with this chord is equal to any angle that comes off of that chord. So this is 60, so any angle that comes off of B and D in this direction will also be 60 degrees. It's called the alternate segment theorem. So ABD is 60 degrees because of the alternate segment theorem. Question 15. Prove algebraically that 0.73 recurring can be written as 11/15. So we'll call 0.73 recurring x. We want something that ends in, well, two things that end in 3 recurring. So if we multiply by 10, so 10 times x will be 7.3 recurring. And then multiply by 10 again, so 100 times x will be 73.3 recurring. So now we can eliminate this 3 recurring by taking away. So I can do 100x take away 10x. 100x take away 10x is 90x, and 73.3 recurring, so 73.333 take away 7.3 is 66. So these recurring bits cancel out. We've taken one away from the other one, so it's cancelled out. That's left us with 66 equals 90x. Now we can divide both sides by 90. So x is 66 over 90. And that will simplify. So 66 over 90 simplifies to 11/15, dividing top and bottom by 6. Question 16. Here's a speed time graph for a car. Work out an estimate for the distance the car travelled in the first 30 seconds. So when we have a speed time graph, the distance is the area under the graph. So we want to work out an estimate for this area under here. And what we can do is we can draw a triangle. So we can draw a triangle up to here, and then down to 0. And we can work out the area of this triangle, and that will be an estimate for the area under the graph. So the area of a triangle is half times the base times the height, and the height is 9. So half times 30 times 9 is 135. Part B. Is your answer to part A an underestimate or an overestimate of the actual distance the car travelled? Give a reason for your answer. So we can see it's an underestimate because the curve goes over the triangle. There's part of the curve not included in the triangle. So we've underestimated because part of the curve, or area under the curve, part of area under the curve is not included in the triangle. So this green bit here, we haven't counted, so we've underestimated. Julian used the graph to answer this question. Work out an estimate for the acceleration of the car at time 30 seconds. Here is Julian's working. So at time 60 seconds, speed 13 times 60. Let's have a look. So at time 60 seconds, he's done speed 13 times 60. So he's worked out the average acceleration. So it is 1360, but at time 60 seconds, he should have drawn a tangent on. He should have drawn a tangent and worked out the gradient of this line. So to work out the acceleration at a point, you draw a tangent on, and work out the gradient of the tangent. He has worked out the average acceleration up to that point. So he's worked out the acceleration of this line. So the average acceleration up to 60 seconds, not the acceleration at time 60 seconds. So he should have drawn a tangent and worked out the gradient of this line, but he has worked out the average acceleration in the first 60 seconds. So he should have drawn a tangent at 60 seconds. He worked out average acceleration in the first 60 seconds. Question 17. The histogram gives information about the distances 80 competitors jumped in a long jump competition. So we've got a histogram drawn here. The question says calculate an estimate for the mean distance. So usually when we have estimate the mean, we're given information in a table. But this time we haven't been given a table, so we need to work out the frequencies ourselves. And we can do that by working out the area of the bar. So for the first bar, it's base is 6.4 to 7.2. That's 0.8. And 10 tool, 0.8 times 10 is 8. We've got 0.4 times 50. Remember, we can use a calculator. 0.4 times 50 is 20. We've got 0.4 again. So 7.6 to 8 is 0.4. And it's 100 tool. So 0.4 times 100 is 40. And we've got 0.2 times 60, which is 12. So now we know the frequencies. So we do midpoint times frequency. So 6.8 times 8, 7.4 times 20, 7.8 times 40, and 8.1 times 12. So that will give us the total, and then we divide by how many, so that will give us the total distance travelled by everyone, and then divide by how many, which is 8 plus 20 plus 40 plus 12, which I'll work out quickly. So 20 should be 80. So then we'll divide by 80 because there are 80. Oh, we were told that 80 competitors. So 6.8 times 8 is 54.4. 7.4 times 20, 148. 7.8 times 40, 312. And 8.1 times 12, 97.2. So we'll add all these numbers up. Which is 611.6. And then divide by how many, which was 80. So divide by 80, 7.645. 7.645 meters. And that looks sensible. It's in this 7.645 looks to be somewhere in the middle of all of them. So it's a sensible answer. Question 18. The diagram shows a cube. AH is 11.3 centimeters. So A to H is diagonal along here. 11.3 centimeters. Correct for the nearest millimeter. So we've got a bounds question. Calculate the lower bound for the length of an edge of the cube. So the lower bound for this, so this has been rounded. The one below is 11.2. So the lower bound for this measurement will be 11.25. And we want to know the edge of an edge of a cube. So we can use Pythagoras twice. So this is a length, this is a length, and this is a length. And we've got a right angle triangle here, and a right angle triangle here. We know that the length squared plus length squared square rooted is this length. And then this squared plus this squared equals this squared. And for 3D Pythagoras, we can actually say the square root of L squared plus L squared plus L squared equals 11.25. So L squared plus L squared equals this diagonal squared. So the diagonal squared is L squared plus L squared. And for the one up here, the one with 11.25 in, L squared plus the diagonal squared equals 11.25 squared. So the diagonal squared is L squared plus L squared. So we can change that into there. So it's actually L squared plus L squared plus L squared equals 11.25 squared. So we want to know what L is. So we've got 3L's the square root of 3L squared equals 11.25. So we square both sides. We didn't really need to square root. 11.25 squared is 2025 over 16. So 3L squared is 2025 over 16. Divide both sides by 3. 675 over 16. And then square root both sides. Square root the answer. So I've got 15 root 3 over 4. Or 6.5. 6.5 centimeters to one decimal place. Question 19. So ABCDEF is a regular hexagon with sides of length x. So ABCDEF, that's our smaller hexagon. The hexagon is enlarged, center F, by a scale factor P to give hexagon the bigger hexagon, FGHIJK. So the length of the smaller sides are x, and the length of the sides of the bigger hexagon has been enlarged by P, so they're called PX, P times X. Show that the area of the shaded region, so the area of the big hexagon, take away the area of the small hexagon, is given by 3 root 3 over 2 times P squared minus 1 times X squared. So to find the area of this hexagon, find the area of a hexagon, we can split it into triangles. So if we draw a line connecting all the opposite points, opposite corners, we split they're all a line of symmetry. They all split the hexagon exactly in half. And what we end up with are equilateral triangles. So we've got 6 equilateral triangles here. So each angle is 60 degrees. You could say we've got half of the interior angle of a hexagon, which is 120. So each one is 60. So each angle is 60 here. And we can work out the area of the triangle. Area of a triangle, we can use half base times height, or we could use half AB sine C, because we know that this length is going to be x as well. It's an equilateral triangle, so that's x and x. It doesn't matter which one of those we use. We can use SOHCAHTOA to find the height and do half base times height, or we can use half AB sine C. Either way, we're going to end up with the same area for each one of these triangles. Let's use half AB sine C. So the area of each of these, get rid of this line, the area of each of these equilateral triangles, so area of the triangle is half AB sine C, which is half times x sine 60. Sine 60 is root 3 over 2. So it's half times x squared times root 3 over 2. And 1 times root 3 is root 3. 2 2s are 4. So we've got root 3 over 4 x squared. That's for each triangle on an ABCDEF. For the bigger one, for the bigger hexagon, the area of each triangle will be half times px sine 60, which will be sine 60 still root 3 over 2. Half times root 3 over 2 is still going to be root 3 over 4. Let me just write this first. So p times p is p squared. X times x is x squared. And sine 60 is root 3 over 2. So root 3 times 1 is root 3. 2 2s are 4. And we've got p squared x squared. We've got 6 triangles that make each hexagon. So root 3 over 4. So root 3 over 4 times 6 is 3 root 3 over 2. So the area of ABCDEF is 6 times this, which was 3 root 3 over 2 x squared, and the area of FGHIJK will be 3 root 3 over 2 p squared x squared. So the shaded area is the big one, take away the small one. So shaded area is 3 root 3 over 2 p squared x squared, take away 3 root 3 over 2 x squared. So if I factorize out 3 root 3 over 2, 3 root 3 over 2, I just factorize that out first because we need 3 root 3 over 2, and we've factorized out x squared as well, but they've put it at the end. Let's take out 3 root 3 over 2 x squared, and we can move the x squared afterwards. So factorizing out 3 root 3 over 2 x squared just leaves p squared and minus 1. So moving the x squared to the end, 3 root 3 over 2 times p squared minus 1 x squared. Question 20. Here's a list of 5 numbers. Find the lowest common multiple of these 5 numbers. So we've got 98 to the power of 53, 98 to the power of 64, 98 to the power of 73. So they're all 98s times together. So the lowest common multiple is the lowest number in all of their times tables. So we don't usually think of the 98 to the power of 53 times table. So this means 98 times 98 times 98 times 98, 53 times. 98 to the power of 64 is a multiple of 98 to the power of 53 because you just need to multiply it by 98 another 11 times. And 98 to the power of 73 is a multiple of the ones that are lower than it because you just need to multiply them by 98 to get there. So the lowest common multiple will be 98 to the power of 91, which is 1 times 98 to the power of 91. And you need to multiply 98 to the power of 88 by 98 to the power of 3. You can get to 98 to the power of 91 by multiplying each of these by 98, and 98 to the power of 91 times 1. So it's in all their times tables, so that's the answer. And question 21. So 5c plus d equals c plus 4d. Find the ratio of c to d. So let's take c away from both sides. So we get 4c plus d equals 4d. And then take d away from both sides. So 4c equals 3d. Now we can write this as a ratio. The ratio of c to d. So the quick way is to say you just flip these numbers over. So it's 3 to 4. What you can also do is you can look at numbers that work for these. So if c is 3, when c equals 3, we've got 4 times 3 equals 3d. So 12 equals 3d. Divide both sides by 3, d equals 4. So when c is 3, d is 4. Or if we said c is 1, when c equals 1, we'll have 4 times 1, which is 4, equals 3d. Divide both sides by 3, d is 4/3. So c to d is 1 to 4/3. And then multiply both sides by 3, we get 3 to 4 again. So the ratio of c to d is 3 to 4. Part B, so we've got 6x squared equals 7xy plus 20y squared, where x is bigger than 0 and y is bigger than 0. Find the ratio of x to y. So again, like the last question, we kind of want to solve this, but it looks quite complicated. So if we make it equal to 0, so take 7xy away from both sides, take 20y squared away from both sides, then we can actually factorize. So we're going to have an x as both of the first terms and a y as both of the second terms. So we'll have, we can do a times c, or should we just go for it? We'll do a times c. So 6 times negative 20 is negative 120. What multiplies to give us our 120 and adds to give us a 7. So 1 times 120, 2 60s, 3 40s, 4 30s. It's 5 times 24, 6 times 20. It's not in the 7 times table. 8 15s, and that will give us our 7. So 8 and 15. So if I say I've got 6x squared plus 8xy minus 15xy minus 20y squared equals 0. What can I take out of these first two? What could I factorize out of these first two? So it's both in the 2 times table and they've both got an x in. So 2x. 2x are in both of these first ones. So 2x times something gets me 6x squared. 2x times 3x will get me 6x squared. 2x times something will give me 8xy. 2 times 4 is 8, and 2x times y give me xy. Then we've got minus 15xy, so it must be negative 5y times 3x for negative 15xy. And then we've got negative 20y squared, so negative 5 times a positive 4 will give me a negative 20. So I've got 2x minus 5y and 3x plus 4y as my two brackets. So 2x minus 5y equals 0, or 3x plus 4y equals 0. So 2x equals 5y, or 3x equals negative 4y. So we can say x to y, so switching them over is 5 to 2, or x to y is negative 4 to 3. Now we were told x and y are both positive, so it must be the 5 to 2. So x is 5 parts and y is 2 parts.